Last we have drawn the diagram of transistor as an amplifier. Hello?
Yeah, sir.
Diagram we have drawn for transistor as an amplifier.
हाँ सर.
Okay, फिर से एक बार देख लो. We have to show that amplifier is giving more current, more voltage, more power. So alternating source which is to be amplified is superimposed along with the base voltage VBB. So once again see the circuit diagram. This is N, P, N transistor. N, P, N transistor. Collector, base, emitter. The alternating signal which is to be amplified is superimposed along with VBB. VBB is constant but signal is changing. So varying base emitter voltage is connected across base emitter, which produces changing current IB. Due to this, varying collector current IC flows through collector. This is VCC. Plus is connected to minus so that it behaves reverse biased, and output is obtained between collector and emitter. This much I think you all had drawn in the last lecture, correct? Hello?
Yes, sir.
Now right answer. The alternating signal Vs, which is to be amplified, is superimposed along with base voltage VBB. Thus, varying voltage delta VBE is supplied across base and emitter. Base and emitter. Hence, delta IB flows through base. Thus, delta IB flows through base. This produces varying current delta IC through collector. This produces delta IC through collector. Once you complete till this, please tell. Yes, completed. Hello, completed till this.
Yes.
Okay. So just now we have only explained circuit that VB is given as input, which is varying in nature. So base current IB is also varying in nature. Because of that, collector current also varying in nature. What is beta defined as? Are you remembering? Don't remember, I think.
अल्फा अपॉन 1 माइनस अल्फा.
वो तो ठीक है, बराबर था. In terms of definition में तो ऐसा था ना, delta IC upon delta IB. So since beta is delta IC upon delta IB, so delta IC is beta delta IB. Since beta is greater than 1, so delta IC is greater than delta IB. मतलब करंट ज्यादा मिला अपने को. Thus, current gain is obtained. Current gain is obtained. Write this one. Then we'll check how voltage gain is obtained. करंट भी ज्यादा, वोल्टेज भी ज्यादा, पावर भी ज्यादा, इसलिए इसको यूज करते हैं सबसे ज्यादा. और yes, Aryan Purandare completed. हाँ हो गया ना इधर तक.
हाँ सर.
ओके, अभी देखो मैं क्या करता हूँ, इनपुट साइड को रब कर देता हूँ और खाली आउटपुट को रखता हूँ. यू टेल मी क्या क्या है आउटपुट में. This is our output side. Base, collector and emitter is output. What is Kirchhoff's voltage law? In an electrical network, algebraic sum of potential drop and EMF enclosed in a closed circuit is always 0. Okay. Hello.
Yes, sir.
So if I start from A, go to B, C, D, and back. Now you tell me, A to B, will there be any voltage drop? A to B? Will there be any voltage drop? नहीं होगा ना, क्योंकि इसमें रेजिस्टेंस नहीं है ना.
Yes, sir.
So there won't be any voltage drop. B to C battery है. Minus to plus. Should we write plus? When we go minus to plus, we write plus now. अब ये we are in the direction of current. So minus ICRL. Current flows from high to low. So plus to minus, minus voltage between CE equal to 0. It's called by Kirchhoff's voltage law. ये लाइन समझ में आ गया? By Kirchhoff's voltage law, VCC is VCC minus ICRL minus VC is 0. That means VCC is ICRL plus VCE. Tell me, have you followed everything till this in output side?
Yes.
Because इसके बाद ही दो लाइन है, नहीं समझा तो मैं आपको ओम्स लॉ से समझाता हूँ. I'm just turning this in. This is resistance RL. Okay. ये बैटरी का प्लस ये साइड पे, ये माइनस. Here there is that collector. फिर ये मैं एमीटर नाम देता हूँ इधर बीच में. This is collector, वायर के साथ जाके एमीटर. So collector डिजाइन बनाने का जरूरत नहीं है, स्ट्रेट ऐसा बना दिया. So can I say that this battery is supplying voltage to this plus voltage to this? Answer क्या? If this is one resistance, this is another resistance, this is battery. तो बैटरी किसको किसको वोल्टेज देता है? इसको भी देगा और इसको भी देगा ना. Hello?
हाँ, sir.
So this whole part is our one resistance. The voltage across that is VCE and voltage across RL is ICRL. So this battery is giving voltage to ICRL plus VCE or not? So can I say battery voltage is ICRL plus VCE, or I use Kirchhoff's law, meaning is same na? Yes, Patil. Again explanation followed. Aryan Singh. Aryan Singh, you followed?
Yes, sir.
What is Kirchhoff's voltage law? Total voltage is 0. This is Kirchhoff's voltage law.
Yes, sir.
And whenever you go from low to high, we say plus. So I started from here, A to B, no drop because the resistance nahi hai. Here there is no resistance, there can't be any drop. Then minus to plus is plus. ICRL in the direction of current minus. C to E, you are going from current ka direction mein. So positive to negative is minus and 0. Therefore VCC is ICRL plus VCE. Who has not followed this formula? By Kirchhoff's voltage law, VCC can be written as ICRL plus VCE. So anybody has not followed, please ask, because our entire thing now will depend upon this formula. So I hope everybody has followed. Correct? Anushka, Divina, you all have followed this? Viti?
Yes, sir.
Manasvi?
Yes, sir.
Okay.
Yes, sir.
Manasvi ko bhi samajh gaya. So if I put delta, delta means chain, then everywhere I should put delta algebraically. Everywhere you can do anything. What is VCC? Battery ka voltage na? Which is fixed. If VCC is fixed, that means there is no change in battery. change in battery voltage is 0. So 0 equals to delta ICRL plus delta VC. Tell me, followed or not? Change in battery voltage is change in ICRL, change in VCE. But battery तो fix है, तो उसका change 0 होएगा. Clear?
Yes.
So can I say delta VCE is minus of ICRL? VCE means output voltage is minus ICRL. Some of you will say, sir, what is meaning of negative? So I will say negative means there is phase shift of 180 degree in output. Now why there is phase shift of 180? Check here. If this is VBBE, which I told earlier also, suppose it is 5 volt and signal is 1 volt plus or minus, so it will give you answer 5, 6 and 4 का बीच में. So 5, 6, 5, 4, 5 ऐसा it will alter, but it will never become negative. Now when this VBE is becoming 5 to 6, then IB will increase because voltage is becoming higher. So IC will increase. That means ICRL will increase. But you want net change should be 0. For example, if VCC is 20, ICRL 10, VCE is 10. So if this 10 becomes 11, then this 10 should become 9. So that total should remain 20 only because VCC is not changing. So when this is increasing, then this one is decreasing. That means when ICRL is increasing, then output will decrease. Now if VB is decreasing, IC decreasing, ICRL decreasing, output is increasing. So can I say when this is crest, then this is trough. When this is trough, then this is crest, not followed. Hello? Hello?
हाँ सर.
तो इसका मतलब जब ये इनपुट क्रेस्ट है तो आउटपुट ट्रफ है ना. तो फेज शिफ्ट कितने का है? Crest becomes trough. What is phase difference? 180 or not?
180.
So negative sign indicates that there is phase shift of 180 degree. Okay? Negative sign indicates that there is phase shift of 180 degree. So negative sign shows that there is phase shift of 180 degree. Voltage gain AV, A means amplification, V is voltage, is output voltage upon input voltage. Please write till this, then I'm explaining further. By Kirchhoff's voltage law, please write. Anywhere you don't understand, immediately ask me that lines. Vedant, you are there still? Vedant?
Yes, sir.
How much you want to score in 12th final exam? As per that, I will plan. How much you want to score?
Above 90.
Above 90. तो 100 ले लेते हैं ना. तो मंडे से बराबर घोड़े पे आना, जाना नहीं किधर. घोड़े को पार्क कर देना.
हाँ सर.
हाँ, बिकॉज रिवीजन स्टार्ट करने वाले अभी. आप एमसीक्यू भी बैठो because first 16 question is related to easier MCQs.
Yes, sir.
Because you will have 8 MCQs, one liner, then 10, 1 mark. They are not like MCQ. by Kirchhoff's voltage law. VCC minus ICRL minus VC is 0. So VCC is ICRL plus VCE. Completed with this?
Yes.
Okay. Viti, how to read this, Viti? How to read this?
Delta.
Delta VI, na?
Yes.
That means change in input voltage. By Ohm's law, what is voltage? V equal to IR. This is voltage by Ohm's law.
Yes.
So if I want out input voltage, then I can also say it is nothing but input resistance, which I write Ri into input current, which is delta I. IR formula IR. because voltage
Yes.
is changing, current is changing, R is constant because ratio is constant. What is IC upon IB in notation? Beta, na?
Beta.
Beta. IC upon IB is beta, and IC upon IE is alpha. And Kano said at the start, relation between alpha and beta is alpha equals to beta upon 1 plus beta, and beta is alpha upon 1 minus
Minus of.
alpha. टेक्स्ट बुक में रॉन्ग दिया है, उल्टा कर दिया टेक्स्ट बुक वाले ने, स्टेट बोर्ड वाला टेक्स्ट बुक ने रॉन्ग दे दिया. So I can say this means AV is beta RL upon RI. Is beta greater than 1? Is beta value greater than 1? सोच के बोलो ना, ये सबसे ये बहुत छोटा है ना, तो बीटा विल बी ग्रेटर देन 1. 50 और 200 के बीच में है.
Yes, yes.
एंड लोड रेजिस्टेंस मतलब हाई रेजिस्टेंस, तो वो भी ग्रेटर देन 1 है. इनपुट रेजिस्टेंस कम है, फॉरवर्ड बायस्ड का वोल्ट रेजिस्टेंस है, तो ये भी ये कम है, लो है ये. सो दिस होल रेशियो विल बी व्हाट, ग्रेटर देन 1 और लेस देन 1?
Greater.
Greater. Why? Because beta is greater than 1, RL is greater than 1, and RI is very small. Load is in kilo ohm and input resistance is in ohms. So definitely numerator is greater. So I can say thus voltage gain is obtained. Voltage gain is obtained. What is 1 upon R called as? Anybody knows 1 upon R?
Conductance.
वेरी गुड, कंडक्टेंस. तो 1 अपॉन आर आई भी कंडक्टेंस के जैसा ही होना चाहिए, है ना. 1 अपॉन आर आई समथिंग कॉल्ड एज कंडक्टेंस ही होना चाहिए, पर इधर बीटा है, तो दिस बीटा अपॉन आर आई का एक नाम है ट्रांस कंडक्टेंस. दैट मींस बीटा मींस करंट ट्रांसफर हो रहा है, IB is going to IC साइड, तो ट्रांसफर, और 1 अपॉन को बोलते हैं कंडक्टेंस. तो टुगेदर रेशियो का नाम क्या पड़ गया, ट्रांस कंडक्टेंस, डिनोटेड बाय G. So beta upon Ri is called as trans conductance, denoted by Gm. So one year in JEE main they had asked trans conductance is this much, what is voltage gain if load resistance. So many students were not knowing meaning of trans conductance, they omitted that sound. So AV becomes now trans conductance into load resistance because that ratio is called trans conductance. What is power? Product of voltage and current. Correct now for current electricity, I know. So can I say power gain is voltage gain into current gain? And current gain is nothing but beta. Any doubt till this at least? All the doubts are clear? Numerical comes, then it will be on this only topic. Just copy till this first.
Yes, sir. Done.
Okay. एक थोड़ा सा लाइन है. So power gain we got, voltage gain AV into AI. Let us check whether that is greater than 1 or not. The common sense say voltage be greater than 1, current be greater than 1. So power will be greater than 1. AV is a beta into RL upon RI, and AI is beta. So this is beta square RL upon RI, which is greater than 1. Thus, power gain is obtained. Hence, widely we use common emitter amplifier because we get power gain, voltage gain, current gain. Conclude till this. Completed full? Hello, completed?
Yes.
Okay. Right. Analog signal. Meaning of analog signal and digital signal. This is alternating signal, correct? This is which type of signal? Alternating. Also called as sinusoidal. So the signal which is alternating is called as sinusoidal signal or analog signal. So if this is given to the input, then generally output signal also keeps on varying according to the input signal. So they are called analog. Time varying signals are called analog signal. Digital means what? A signal which has only two discrete values, continuous nahi rehta hai, discrete values. A signal having only two discrete values, 0 and 1, or low and high, they are called digital signal. Now low stands for 0, high we write for as 1, but actually it is plus 5 volt. So all the electronic circuit which works on digital signal, they are called as digital electronic circuit. So when we say digital electronic, so we are not giving input like this. We give either high or low, not continuously increasing, decreasing, increasing, decreasing. Right? Meaning of analog signal. The time varying signal The time varying signal is called as analog signal. The sinusoidal signals are analog signal. The sinusoidal signals are analog signal. The sinusoidal signals are analog signal. Then write digital signal. A signal which can have only two discrete values is called a digital signal. Example. A square wave is example of digital signal. Next line. After completed diagram, square waveform is digital signal. Next slide, right? In digital circuit, in digital circuit, in digital circuit, the output voltage has only two values. Only two states it is called. Two states. Either low means 0 volt, or high, that is plus 5 volt. An electronic circuit that handles only digital signal is called as digital circuit. The branch of electronics which deals with digital circuits. The branch of electronics which deals with digital circuit is called as digital electronics. And write logic gates. After writing logic gate, we will study 5 types of gate with its symbolic representation, truth table, boolean expression. फिर उसके बाद खाली 4 PN junction diodes are left out. That will complete our entire syllabus once I complete MCQ. Logic gates. Right. A digital circuit. A digital circuit with one or more input. A digital circuit with one or more input, but only one output. The digital circuit with one or more input, but only one output is called as logic gate. It behaves like switching circuit. Switching circuit मतलब on off जैसा. It behaves like switching circuit that follows certain logical relationship. It behaves like switching circuit that follows certain logical relationship between input and output voltage. It behaves like switching circuit that follows certain logical relationship between input and output voltage. Hence, they are called as logic gates. Hence, they are called as logic gates. बाई चांस अगर पूछ लिया व्हाट इज मीनिंग ऑफ बूलियन एक्सप्रेशन, एक लाइन नीचे लिखता हूं उसका. द मैथमेटिकल लॉजिक यू हैव डन ना, उसमें है क्या बूलियन आपको? बूलियन अलजेब्रा.
हाँ सर.
अभी इसमें कभी कभी पूछ सकते हैं व्हाट इज मीनिंग ऑफ बूलियन एक्सप्रेशन. सो वन लाइन राइट नाउ.
पिछले साल सीएस में था.
हाँ सीएस में भी है बराबर.
सीएस में पूरा हो गया सर, वो लास्ट का पार्ट एकदम सेम टू सेम है.
अच्छा ठीक है, तो आपको एडवांटेज है ना इसमें स्कोरिंग के लिए. द मैथमेटिकल स्टेटमेंट दैट provides the relationship between the input and output of a logic gate is called as Boolean expression. The mathematical statement that provides a relationship between input and output of logic gate is called as Boolean expression. Completed?
Yes.
अभी लाइन से एक एक गेट सीखते हैं. फर्स्ट वन और गेट. Suppose I study 3 subjects: physics, chemistry, maths. Government gives proposal either physics or chemistry or maths. That means they are interested in any one or all the three?
Anyone.
Any one. So if any one is maximum, they will consider that. In parallel circuit, if these two resistors are not working, will the current flow or not? This is parallel circuit. This two are, it will flow. ये थर्ड वाले से ना, दोनों वर्क करेगा तो भी फ्लो होएगा,
हाँ.
और तीन हुआ तो भी फ्लो होएगा.
हाँ.
So it will function if either one switch or two switch or both are working. But when both are damaged, then only it will not function. Na? So OR gate behaves like parallel switches, where it will give output even when only one switch is open or both are open, but will not give output if both are open. One should be at least closed. Followed what is meaning of OR gate?
Yes.
देखो मेरे पास 3 सब्जेक्ट है, पीसी है, मैं तीनों में भी अच्छा मार्क लाऊं, क्या फर्क पड़ेगा? एक में ही अच्छा लाया तो भी चलेगा बिकॉज और बोला है, लेकिन सब में खराब आया तो नहीं चलेगा. So when at least one is functioning, at least it will give the output. 2 are functioning, it will give. 3 are functioning, it will give. None is functioning, it will not give. उसको बोलते हैं OR gate. So एक शॉर्ट में लिखता हूँ, it behaves like switch in parallel, switches in parallel. Hence, it will produce output as 1 when even one input is 1. Symbolic representation. Symbolically, it is represented as ये diagram. Two input A and B, one output, suppose X, Boolean expression is X equal to A plus B. प्लस मतलब 0 प्लस 1 किया तो भी 1, 0 1 प्लस 0 किया तो भी 1, इसलिए प्लस है. Right, then I'm showing truth table. Oh, sorry. Truth table. A, B, A plus, 1, 0, 1, 0, 1, 1, 1, 1, also 1. Only when 0, 0, it will be 0. This is truth table. Completed first gate or gate, which is like 2 switches, 3 switches in parallel. एक भी बंद है तो काम करेगा नहीं तो. Shall I clear full? Second one, and gate. It behaves like 2 switches in series. It gives output only when all inputs are high. Symbolic representation. Two input AB and one output X. Boolean expression is X equals to A dot B. It behaves like multiplier. 0 into 1, 0, 1 into 0, 0, 1 into 1 is only 1. So Boolean expression is X equals to A into B. Draw. Write that and draw the symbolic representation.
Done, sir.
and write truth table. A, B, X is A dot B. 1, 0, 0, 0, 1, 0, 0, 0 is also 0, but 1, 1 is giving output. Right, truth table. Is completed? Not gate. See, not means negation. Somebody is telling 0, other person is telling no, it is 1. कोई बोलता है हाई, बोलता है नहीं लो. So उल्टा को हम लोग not बोलते हैं, not gate. So this gate inverts the output. That means 0 it becomes 1, 1 becomes inverts the output, or we can say inverts the signal. Symbolic representation it has only one input and one output. So if this is A, this is X. Boolean expression is X equals to A dash or A bar we say. It is also called as complement. A ka complement is A bar or that A dash. It has only one input and one output. Truth table is as shown. Okay, write it first. Then truth table I am doing. Yes, completed.
Yeah, sir.
Yes, sir.
Fourth one, NOR gate. NOR means और नहीं है. NOR gate will invert the output of OR. It is OR gate connected with NOT together. So either this way it is represented, or there is a circle at the vertex that gives inversion, that indicates inversion. So this is its symbolic representation. Boolean expression is x equals to a plus b complement. Truth table will be a, b, a plus b, then x is a plus b का complement. 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0. So this will give you output as 0, 0, 0. Draw this and write truth table.
Done, sir.
Okay. Fifth one, NAND gate. NAND gate. NAND gate means not AND. Not AND मतलब उसका उल्टा. So fifth one is NAND gate. It is AND gate followed by NOT or it is shown like this. This is X, AB, AB, X. A dot B का complement. So 0, 1, 0, 0, 1, 0. Output will be dot ka complement. So you will get here 1, 1, 0, 1. Right. Draw diagram, Boolean expression, truth table. Sixth is called exclusive or XOR gate. Exclusive OR. Better?
Yes, sir.
Right. It produces high output only if one output is high. Only if one output is high. It produces high output only when one of the input is high. If there are more than two inputs, then it gives high output only when odd number of input has value 1. Odd number of input has value 1. Then write symbolic representation. Symbolic representation. Is A, say a Boolean expression is A plus B circle में और A complement B plus B complement A. Truth table. A, B, C gives output only when one of the input is high, not both. It gives output only when one of the input is high. Both 0, no output. Both 1, no output. Completed?
Yes, sir. Completed.
Full completed? One numerical I am doing that. This is 19th question from textbook of State Board. In a common base connection, a certain transistor has an emitter current of 10 milliampere and collector current of 9.8 milliampere. Calculate value of base current. Emitter current 10 milliampere, collector current 9.8, find base current. See how simple the sum is. Emitter current means IE 10 milliampere. Collector current IC 9.8 milliampere. Base current IB we want. For transistor, whichever type it may be, always IE is IB plus IC. So IB will be IE minus IC. Therefore, IB equals to 10 minus 9.8 equals to 0.2 milliampere. These are 1 mark questions asked in MCQ. Copy. Yes, completed. Okay. So I'm just clearing this off. That's all for today. One more lecture we'll be able to complete